Good evening, students. Today we'll try to find the definite integrals to evaluate definite integrals using substitution method. So now we'll try to see how we can find. Okay, so we have to evaluate definite integrals. Definite integrals. Evaluate definite integrals using substitution. Okay, so let us begin now with examples how we can do that. So now let's begin with first question. Now I have my first question in my hand, that is we have x upon x square plus 1 dx. So now we'll evaluate this definite integral using substitution method. How? Let us see. First, put x square plus 1 is equal to t, 2x dx is equal to dt. So x dx is equal to dt upon 2. So we can write here, that is, you can write now x dt upon t. But now here limits will also change. How? If I put x is equal to 0 here, so t will be 1. If I put x is equal to 1 here, so t will be 2. Limits will also change. So now what I have, integration 1 upon t will be log t. So I got log t plus c. Okay, so that is how we can do it, log t plus c. Now wait, now we got log t plus c. Here we will try to put the value here, that is we'll put t at 2 minus log 1. So I got log 2 upon 1 is equal to log 2. Okay, so that is how we can easily evaluate definite integral using substitution method. Now we'll move to the second question. Now second question I have, that is now we'll try to solve the next question. Now the next question I have, that is 0 to x plus 2. Okay, now we'll see. Now we'll put x plus 2 is equal to t square, so that dx, so that x plus 2, wait, we have to see what they have given. X plus 2, put x plus 2 equal to t square. Okay, 2 is equal to t square, so that dx is equal to dt. So that we can put here dx is equal to 2t dt. Okay, so we'll take 2 outside here. So now we have taken x plus 2 t square, so it will be t, and what will be x here? X will be t square minus 2. Okay, so now I have this. Okay, so now we can put like this. So dx will be, what will be dx here? We have taken this t square. Okay, so it will be t, and we'll see what is x here, that is t square minus 2, and we have dx here 2t dt, to 2 outside, to t dt. Okay, so here what we have got is, and also limit will change. Like if I put x is equal to 0, so if I put x is equal to 0, so t will be root 2. If I put x is equal to 2, will be 2. Okay, so now we'll integrate first. T4 minus 2t square dt, here root 2 to here. So what will happen when we integrate? I got my value, that is t5 upon 5 minus 2t cube by 3. Now here we want to put the value to root 2. So I got 2 here. Now we'll sort it out. If I put t is equal to root 2, so we'll got 2 is equal to 5 upon 2 upon 5 minus, no, first we'll put the upper limit, no? So if I put t is equal to 2, 2 is for 2, 32 upon 5 minus 2 to the 4 to the 8 upon 2 to the 4 to the 8 to the 16 upon 3. Okay, minus, now I will put the value here. Now I will try to solve. 2 will be 5 upon 2 upon 5 minus, here I put 3, so 3 by 2, okay, 3 by 2 plus 1, so I will got 5 by 2 upon 3 here. Okay, so likewise I can solve it further. That what I got here, if I try to solve this is I got 15, so 5, 3, 32 into 3, 3 to 6, 9 minus 5, 60, 80. Minus, now 2 I have, so now I can take this value, that is what I can take 2 5 by 2 common, so here I will get 1 by 5 minus 1 upon 3. Okay, so here I got 16 upon 15 minus 2 square 5 upon 2. Now I got 15, 3 minus 5. So 16 upon 15 I got here minus 2. So it will be plus 1. So you will get here 7 upon 2 upon 15. If I multiply, I got 32 upon 15 plus here I will got, if I multiply 2, 9 upon 2 upon 15 I got. Okay, so that is how I can easily solve, so using evaluate definite integral using substitution. Okay, now let us move to the third numerical. This is, we have solved 2 numericals. Now let us see how we can solve. Now we'll try to solve the next numerical. Let us see how we can solve the question. Now they have given, that is sin phi, we have cos phi d phi. Okay, this is a question we have, and now let us try to solve how we can easily solve this numerical, and they have given 0 to pi by 2. And this type of integral, what we can do here is put sin phi is equal to t, but before that we can write cos phi as cos 4 phi and cos phi d phi, and here I have sin phi, here 0 to pi by 2. Now put sin phi is equal to t. Okay, so that we have cos phi d phi is equal to dt, and cos 4 I can put cos square phi, so we can write cos square is 1 minus sin square phi, so it will be minus t square whole square, and here we have dt. Here limits will also change. If I put phi is equal to 0, so t is also 0. If put phi is equal to 90, then t is equal to 1. So that is, now I can solve just we need to put the formula here, a minus b whole square, that is a square plus b square minus 2ab. Okay, now I have this. To sort it out, we can multiply inside root t plus t half plus 4. Okay, so half plus 4, 8 upon 9 I have. Okay, 8 upon 9 minus, if I do this, 2t 3 by 2. Okay, 2 plus half, so you will, no, 2 plus half I am doing, no, 5 by 2, sorry. It will be 5 by 2 dt. Now I can easily integrate them. Half you will got t 3 by 2 plus t plus 1, 17 upon 9 minus 2 t we have I plus 1 2 7 upon 2 upon 7 upon 2. So now I can easily put a value here. I will take 2 by 3, t is about 3 by 2, 9 upon 17, 17 upon 9 minus 2 upon 7. So we have here, have taken this, so it will be t. So t here 7 upon 2. Okay. So now I can put the value here and we'll try to find the answer, that is 2 by 3 plus 9 upon 17 minus 2 upon 7. Okay, because 0 will be 0 here. So now I will got here my answer, that is, if I try to solve, will 17 into 3 51, 51 into 7. Okay, because all three are odd numbers, so we can 35, 137 here. So I got here 137. If I divide by 3, left with, okay, so now wait, we have done a mistake here. T1 into 7, 35. So I'll got here 357. Now if I divide by 3, I got the 3 5 the 3 3 9s are 27. So 119 plus, if I divide by 17, I got 34 and 1 plus, sorry, here it is minus. Now divide 357 by 7, so I got 35 1. Okay, so likewise I can solve, that is 4 minus 51 upon 357. So I got here 140, 100, 11, that is 89 upon 357. Okay, so that is how we can easily solve such kind of evaluate definite integral using substitution. Now we'll try to solve next, try to evaluate next definite integral using substitution method. Okay, so now I will try to solve fourth question. Now we have solved only 3, so now let us try to solve the fourth one I have. Now the fourth question in my hand, that is, they have given, that is, the question is sin x upon 1 plus cos square x dx, and then we have the limit 0 pi by 2. Okay, so now what we can do here, put cos x is equal to t, so that minus sin x dx is equal to dt. So that now I can put here minus outside, so dt upon 1 plus t square. The limit will also change. If x is 0, cos 0 t is equal to 1. If x is 90, x is 90 here, so cos 90 will be 0. Okay, so that is how we can easily solve the numerical. Cos 90 is 0 and cos 0 is 1. So what they have given in the question, let me check again if there is an error or something like. The question they are saying about sin x pi by 2 upon 0. Yeah, sin x upon the thing is given. So now what we can do, let us try to solve the integral here. The 1 upon 1 plus t square will be tan inverse t plus c. Now we can put the value here 0 to 1, but we have minus here. We'll take minus, so tan 0 will be 0 minus tan 1 tan 45, so pi by 4. Okay, so it will be pi by 4. So that is how we able to evaluate definite integral using substitution method. So we have done 4. Now we'll move to the 5th one. Now we'll try to solve the next numerical they have given, that is dx upon, we have the question here, that is the question is we have x square plus 2x plus 5 and we have minus 1 to 1. Now they have given the limit also. Now let us try to solve it. Let this by completing square. So we'll get here dx upon x plus x square plus 2x plus, we can do 2 by 1, 1 plus 5 minus 1. Okay, so now what I will got here is, that is dx upon, that is x plus 1 whole square plus 2 square. Okay, so now we know the formula here, that is 1 upon 2 tan inverse x upon 2. Okay, so that is how we can solve the numerical, that is we can evaluate definite integral using substitution, but there we have to put a limit also. Okay, so that will put, so 1 plus 1 2, 2 by 2 1, so we will have tan inverse 1 minus 1 plus 1 0 0 tan inverse 0. So now what I can do here is half, so it will get pi by 4 minus tan 0, we all know the value 0 will be 0 here, so I will got my answer, that is pi upon 8. So that is how we evaluate definite integral using substitution method. Let us move to the next question. Now let us try to solve the numerical. Let us next evaluate definite integral using substitution method. So now this question will be our, I think let us see what they have given in this question. The question is very interesting. Now what they have given in this is, that is 1 to 2 1 upon x minus 1 upon 2x square e raised to power 2x dx. Okay, so now let us try to solve this numerical. Very easily we can put 2x, we will put, that is x square is equal to t, so that 2x dx is equal to dt. So we have, that is here, what I can try to solve is, now we have x square is equal to t, that is x is equal to root t. Okay, so now what I will get here about the value t. Okay, x square is, I am taking t here, so 1 upon t square. So now we'll try to solve this numerical what they have given in that question. Let me check again. So that is what they have taken in that value, that is they have taken 2x. Okay, so that is how we'll try to solve this. Okay, what they have done is, instead of x square plus t, we can take 2x is equal to t, so that 2 dx is equal to dt. So I'll take half outside. Okay, so now minus t, so now it will, what they have given, if I put 2x is equal to t, 2x is equal to t, so it will be t square. Okay, so just put dt. Now we'll change the limits also. Okay, if x if x is 1, t is equal to 2, if x is 2, t is equal to 4. Now we can directly apply the formula here by parts they have given, that is if e raised power x, fx plus f dash x is given. Okay, to integrate it with respect to dx, we got e raised power x fx. Okay, so we'll have e raised power 2t into 1 upon t. Okay, so now I can directly put the value here. So half will be there. So if I take 1 by 2, e4 4 to the 8, e8 into 1 upon 4 minus e4 1 upon 2. Okay, so that is how we got the value here. If I take 4 LCM, so e8 minus 2e4 1 upon 2, so it will be 1 by 2 e raised power 8 minus 2e4 upon here now I got 8. Okay, so that is how we able to easily find the definite integral using substitution method. I can directly apply this formula here also, but we have to use the substitution method. That's what we are doing. Now let us try to evaluate another definite integral using the substitution method. Okay, so now I have one more question, that is they have given, that is sine inverse. We have sine inverse 2x upon 1 plus x square. Okay, so now how we can do, let us try to solve. What we can do, put x is equal to tan theta, so dx is equal to sec square d theta. We all know that differentiation of tan will be sec square theta. So now we'll try to solve it out. We got sine inverse 2 tan theta upon 1 plus tan square theta, and we can write here sec square d theta. Okay, so I have, now limit will also change. If I use x is 0, so tan 0, theta will be 0. Okay, x is 0, so tan 0, so theta will be 0. And if I use 1, so x will be pi by 4. Okay, so we'll now see, we know the formula 2 tan theta upon 1 plus tan square theta is sine 2 theta, is sine 2 theta, and we have sec square d theta, sec square theta d theta. Okay, so now what I have in my hand, let us try to solve. Now we'll have 2 outside, we have 0 pi by 4 theta into sec square theta d theta. Now how to integrate it, using by parts we can do. First function taking it is a second function, so it will happen theta integration of sec square theta d theta minus, we have integration, differentiation of d theta will be 1 and integration of sec square theta will be tan theta. So now I have this. Now what will happen, sec square theta tan theta, so theta into tan theta minus, here now we'll try to see the integration of tan theta. Okay, now we'll have this plus log cos theta plus c. Okay, now here we need to put the value for this. Okay, so let us see what the value will have in this, that is pi by 4 and 0. Okay, so now we'll put the value, we'll get pi by 4, tan pi by 4 will be 1, so pi by 4 plus, it will be log 1 upon root 2. Now minus, if I put 0, 0, it will be cos 0. So cos 0 will be 1. So it will be log 1. Okay. No, I can't do a plus and plus c. Okay. So now I got this value here. So I got pi by 4 plus log 1 upon root 2 plus c. Because log a plus log b will be log ab. Okay, so that is how we able to solve the evaluate a definite integral using the substitution method. Okay, so now let us try to solve or evaluate definite integral, another definite integral using the substitution methods. Okay, so now let us see how we can able to solve such kind of numerical we have. Now this is what they have given, dx, that is 0 to t 2 upon x plus 4 minus x square. Okay, no bracket they are using it till now. Okay, so now let us see how we can solve it. Take minus sign common here. So what I have got here, x square minus 4 minus x, 0 to 2. Okay, I can use this. Now what I will get here, 0 to 2 dx upon x square minus 4. Okay, then we have plus 1 upon 4. Then we have, okay, so now we can solve like this, x minus 4. Wait. So now I can write here x square minus x minus 4. So now I can take x square minus x plus 1 upon 4 minus 4 minus 1 upon 4 here. Okay, so now my next step will be 0 to 2 dx upon minus x. So here now I will got minus 1 upon 2 whole square, and here I will get minus 17 upon 2 whole square. Okay, 16, no, root 17, sorry, point. Now what I can do here, just I can easily, solve that 17 upon, I can take, that is dx upon root 17 upon 2 whole square minus x minus 1 whole square. Okay, so now I can directly put the formula here, but I have to use the method, that is substitution method, is equal to t, so that dx is equal to dt. Now I will put the formula here for this. What I have got here, that is root 17 upon 2 whole square minus t square. Okay, now a square minus x square, it will be 1 upon 2a into log. Now I will have x plus a upon x minus a. Okay, so now this is what I have. Now I need to put the value also. Here I am taking this value. So if I put x is equal to 0, so t will be minus half, and if I put x is equal to 2, 3 by 2. Okay, so now I got this plus c. Now here I will try to put the value, that is 1 upon, you will get root 17 into log root 17 upon 2 plus t, that is 3 upon 2, and upon 17 upon 2 minus 3 upon 2. Okay, here now the next I have log root 17 upon 2 plus it will be then minus half upon root 17 upon 2 minus, it will be plus half. Okay, plus c. So let us see how we solve this. Now what we can do here, now we have taking 2 LCM here, so I will got 1 upon root 17 by 2 they will be cancelled. So now I have left with 17 plus 3, okay, upon 17 minus 3 minus, here I will have log root 17 minus 1 upon root 17 plus 1. Okay, so now I have this much. Now we'll try to solve the next step. Now the next step will solve here. Okay, so next step will be what we will able to sort it out. So let us see how we can do it here. What we can take root 17, we can take minus sign common here. So taking minus sign will be plus. So now log a plus log will be log I will got here root 17 minus 3 into root 17 plus 1 upon root 17 minus 1. Okay, I have just taken minus sign common here, so it will be plus log a plus log b, formula will be log ab. So now what I got here is, if I multiply this, I will got what? We have log root 17 into root 17. So it will be 17 plus root 17 plus 2, it will be 4 17 root 17, okay, and plus 3 upon, similar here, root 17 minus root 17 minus 4 root 17, and it will be plus 3. So what I got here is 1 upon root 17. So log 20 plus 4 root 17 upon 20 minus 4 root 17. So what I got here, take common, what I can take common, 5 here, so 5 will be reduced. So I got 5 plus 4 root 17 upon 5 minus 4 root 17. Okay, this is what I left with, but I can rationalize again. So when I will rationalize, I will find the answer. So what answer I will get here? 1 upon root 17. Here I can rationalize. So I got 5 plus 4 root 17 whole square upon 25 minus 16 into 17. Okay, 4 root 17 into 4 root 17. So what I will got here? 17 into 16. So 17 2 7 1. So I got 2 7 2 272. So now I got my answer here, root 17 log 25 plus 272 plus 20. Now we'll try to solve the numerical, that is a plus b whole square. So a square plus b square plus 2ab. Okay, so now I got this value. So now I got minus 247. Okay, so now I got this value here. So now I can solve it out to further. I got log, if I add, I will got what, 97 plus 20 root 17 upon minus 247 plus, no, so that is my answer. Yeah, I know it is a long question we have done to evaluate this definite integral using substitution method. So that is how we able to solve. So if you have any doubt, you can ask and comment and share my channel and like my channel also. So we'll try to solve now next definite integral using few properties.